Ravinder? Ravinder, are you
We
there?
are live on YouTube now.
We are live. Okay.
You can
Yeah.
start.
Should I go ahead?
Yeah, please, Malika.
Okay. Good morning, everyone. Happy Guru Purnima to everyone. It is a special occasion, and Miranda House and Ramanujan College welcomes you all to this special day, the Guru Purnima. Today is the 11th day of the Faculty Development Program, Chemistry, the Catalyst for Change. Today, we welcome our first keynote speaker, Professor R.K. Sharma. Welcome, sir. Professor R.K. Sharma is professor at the Department of Chemistry, University of Delhi. He is also the coordinator of Green Chemistry Network Center, established under the recommendation of world leaders of green chemistry, headed by Professor Paul Nestas. He is fellow of the Royal Society of Chemistry and the honorary secretary of Royal Society of Chemistry, London, North India section. He is also a member of the American Chemical Society and the faculty advisor of the International Students Chapter of ACS. After completing his PhD in 1986 from University of Delhi, Professor Sharma worked as JSPS postdoctoral fellow at University of Tokyo and Kumamoto University, Japan. He is the recipient of several prestigious awards like 2010 INSA JSPS Award to visit Japan, 2010 UGC TEC Award to visit Mauritius, 2002 INSA JSPS Award, 1999 World Green Award, 1998 Research Grant Award by Royal Society of Chemistry, London, 1998 Japan Society for the Promotion of Science Postdoctoral Award, 1995 Indo-German Award, and 1995 National UGC National Research Scientist Award. He is a member of the Department of Science and Technology, Government of India's Water Technology Initiative Program Advisory Committee, WTI-PAC, for the evaluation of research proposals. Professor Sharma has published extensively in journals of international repute and supervised the research work of over 40 PhD students. He has delivered many invited lectures at workshops and national and international conferences. Sir, the Zoom is all yours. Welcome once again, sir.
Thank you, Dr. Malika. And first of all, I would like to thank Dr. Sheikh and Dr. Malika for inviting me to deliver a FTP lecture. And just I'm going to share the screen, share my PPT. It's not coming. Just to see, Malika, this is like my PPT is not coming.
Sir, sir, I don't know. Let me check, sir. So you're the co-host? Sir, share screen option green वाला आ रहा है नहीं आपके में?
आता था.
Sir, co-host तो है आप इस समय?
Green share.
Yeah. Now it has come.
Yeah.
Yes, sir. We are also able to see.
Yeah, we can see.
So, as you know, I am from Department of Chemistry, University of Delhi. And recently, a Green Chemistry Network Center established in our department. And this was established under the recommendation of world leaders headed by Professor Paul Nestas, who is known as father of green chemistry. And this network center is working for building a green chemistry network all over India, preparing and disseminating green chemistry educational material, designing trainings, workshops, taking up green chemistry research projects. We had research projects from CSIR, UGC, DST, DBT, industry. And recently we got a major project worth 1 crore from Ministry of Textile for setting up Green Chemistry Network Center Laboratory. So in my talk today, I'm going to touch upon these activities also. But first, let me show you the importance of green chemistry. You see, recently this came in chemical and engineering news. Recently, the US Congress enacted legislation, a law which will promote green chemistry concepts in federal grants. So they will promote green chemistry concepts in grants. But before going to green chemistry, let us see what chemistry is giving us. You know, the chemistry, this is the chemistry which is not only extending the length of the life, which was 47 years and now it is 75 years, but also increasing quality of life by providing so many things. So actually, we chemists are making world worth living. But there is another side of chemistry. Chemistry also leads to toxic world. Chemistry also leads to waste disposal, accidents, toxic emissions, pollution, landfill. And according to the survey done by this Nobel laureate, the humanity's top problems for the next 50 years are energy, water, environment, and food. And more serious problem, he said, it is because of the population growth. 7 billion people in 2011 and expected to be 9 plus billion people by 2050. So population growth is a very serious problem, and especially the countries like India. And this is a very interesting comparison of population. Uh, you just see the population in Indian states uh, and the population in all the other countries like UK, South Africa, Mexico. The whole UK population you just see is equal to Rajasthan's population. Whole South Africa population is equal to Gujarat population. So you see the population growth in India is very serious problem. And because of this, what is happening, the nature provides us the resources. We are consuming resources and creating waste. And nature again converts this waste to resources. And this way the cycle goes on. What we are doing because of the population growth, we are exceeding the carrying capacity of the earth. We are using resources and creating waste faster than the earth can take our waste and convert them back into the resources. So now we are consuming natural capital rather than just the interest. So this is just the one way. Resources, consumption, and waste. So the question arises, green chemistry can help in this regard or can reverse this error? Waste to resources, let us see that also. This is, the picture looks like a graphic art, but it's not. It's again an example of waste. Just take a more closer look, a more closer look, a more closer. 2 million plastic bottles are discarded every 5 seconds in US. And 86% of plastic bottles used in US end up in landfills, taking up to 1,000 years to biodegrade. You just see there's only generation of plastic, no recovery at all. So more serious problem associated with this plastic contamination is 90% floating debris in ocean is plastic. And this is projected to grow tenfold in 10 years. and plastic found in 48 to 80%, 86%. Mammals. More serious problem is that we are using plastic bottles to drink water or hot liquids. So just see, a plastic bottle is containing BPA, a very harmful chemical, and according to the recent research, says that BPA linked to breast cancer in women, brain damage in children, obesity, heart disease, etc. And still we are using plastic bottles to drink water. Again, a picture which looks like Graphica, but it's not. Just take a more closer look. A more closer look. You know, around 4,26,000 cell phones retired each day in US. And India is the second largest mobile phone market in the world after China. And this e-waste, you know what US is doing in terms of recycling of this e-waste? You see that between 50 to 80% of the e-waste collected for recycling in US are not recycled, but it's very quickly placed on container ships bound for destinations like China or India. And this is not a solution. According to the US Department of Toxic Substances, most of the electronic devices are toxic based on 1,000 different substances in e-waste. All these are lead, tin, copper, antimony, cadmium. These are all toxic, all of which can be poisonous to people and wildlife. Even this came in times of India, that Delhi is the second largest producer of e-waste in the country after Mumbai. 3-4 times, Doordarshan invited me in a live show where we talked about green chemistry and impact of waste on environment. So a big question before us is, within the next 50 years, how can we provide 8 to 10 billion people with energy, water, food, quality of life, and future technology? And that is without global warming, without resource depletion, without toxics in the environment. And there is one answer from my side, which I am going to elaborate, is green chemistry. So how green chemistry can help in this regard, I'm just going to discuss about that. But the first question which comes in our mind is what is this green chemistry and why we are talking about green chemistry now? So the first question, what is this green chemistry? I'm just going to define just by taking one slide and one relation. This is a relation that risk is a function of hazard, exposure. If you want to minimize risk, either you minimize exposure or you minimize hazard. Minimizing exposure is the traditional way by putting gloves or safety glasses or helmet or lab coat. This is the traditional way, traditional risk management. But if we can reduce or eliminate this hazard, we can minimize the risk even if there is any accidental exposure. And this is the approach for green chemistry. So green chemistry was defined as green chemistry is the design of chemical products and processes that reduce or eliminate the use and or generation of hazardous substances. So slowly, people started recognizing the benefit of green chemistry. Papers, articles started appearing, but in 2005, Nobel Prize went to green chemistry. and see the comments of the Nobel Committee. This is a great step forward for green chemistry, applying basic science to the problems of man, society, and the environment. So this proves that the best chemists in the world are doing green chemistry. There are two founders of green chemistry, Paul Anastas and John Warner. And they have written this book, Green Chemistry Theory and Practice, published by Oxford Press. So this is a very good book for beginners. And this is already translated into several languages. And in this book, they had written 12 principles of green chemistry. And actually, these 12 principles are the 12 tenets of green chemistry. These principles, they provide a framework for design of new material, product, and processes. And systematic integration of these principles is key to achieving a genuine sustainability for the simultaneous benefit of the environment, economy, and society. So these are the 12 principles, but I'm not going to touch these 12 principles. I'm not going to explain these 12 principles because explaining these 12 principles will require at least one semester. So I'm not going to touch this. Now, the problem of green chemistry is, or the biggest challenge of green chemistry is to get people to adopt, to convince people to do the green chemistry. And we started this mission way back from 1999. National Symposium was organized. Then we had organized IUPAC International Symposium in 2001, which was inaugurated by Sheila Dikshit, that time the Chief Minister. And some world leaders in green chemistry participated. You can see the Terry Collins, Tundo from Italy, then James Clark from UK. So they all participated in this. But what we could find is people were reluctant to change. They don't want to change. And they were taking very lightly about the green chemistry. That time, they were saying that if there is green chemistry, there should be a red chemistry, yellow chemistry, pink chemistry. But we knew that there are always impediments to innovation. Change can come much more slowly than anyone would expect. And simply stated, people don't like to do things differently from the way they have done them before. They don't want to come out of their comfort zone. And new ideas and new perspectives often face harsh opposition. And there are very interesting examples to support this. You know, the Mendeleev, inventor of the periodic table, refused to acknowledge the existence of radiation or even the electron. Even Einstein, the great Einstein, rejected quantum mechanics. He said, quantum theory is certainly imposing, but an inner voice tells me that it is not yet the reality. And more interesting case is with this Nobel laureate, Nobel Prize winner. He won the Nobel Prize in 2011 by discovering the existence of these type of crystals, quasi-crystals. He said when he discovered these crystals, people just laughed at him. Even head of his research group, after telling Daniel to go back and read crystallographic textbook, the head of his research group asked him to leave and leave for bringing disgrace on the team, and I felt rejected. So this happens when you start a new thing. This always happens. So we continued working on the popularization of green chemistry. Even these words of Mahatma Gandhi encouraged us to do the popularization mission. Like he said, first they ignore you, then they laugh at you, then they fight you, and then you win. So we continued the popularization mission, and we found that if we want to incorporate green chemistry principles in industry or in academia, that the best way is by organizing workshops, not by the conferences. So the first workshop we had organized uh, with the support of Indo-US Science and Technology Forum. And this was inaugurated by, this is this man you can see in the middle. This is DST secretary that time. And this man on the right is Paul Anastas. He is the father of green chemistry. He is known as father of green chemistry. And that time he was the scientific advisor to US president, and he came straight from Washington to the workshop and delivered the inaugural lecture. Not only Paul Anastas, all the other world leaders, they participated. You can see the Terry Collins, famous for catalysis work. This is Dr. Mary Kirchhoff, director of American Chemical Society Green Chemistry Institute now. And this is Robin Rogers, famous for ionic liquid work, got the US Presidential Award also. This is John Warner, this is Paul Anastas. Both these two are the founders of green chemistry. So they all recommended that if green chemistry is to grow in India, then there should be a green chemistry networking of different scientists. So we started working on networking also, and started forming a network all over India. And for doing this activity, we got the IUPAC Cameron GCI Den Grant Award continuously for 3 years. And under this, there is a form anyone can fill, there is no fee, and can join our network. For educating school students also, we are going to schools from Delhi and Gurgaon, organize the Green Chemistry Symposium. And you can see I've delivered the inaugural lecture. Every year we are organizing workshop for student teachers, industries. You can see 2009, 10, 11, then this is in 2015. In this, there was the director of American Chemical Society Green Chemistry Institute, David Constable, he came. University of York, Dr. Matharu came. And not only this, the valedictory lecture was delivered by Ashutosh Sharma, who was the DST secretary at that time. This is the photograph. This is Ashutosh Sharma delivering the valedictory lecture. Not only in Delhi, we are touching all parts of the country and delivering lecture, popularization lecture, in conferences or in workshops. You can see Nagpur, Assam, Punjab, Hyderabad, Gujarat, Rajasthan, Gujarat, Sikkim, Punjab, Mizoram, Uttar Pradesh. Then this is Central University, Garhwal, Himachal Pradesh, then Bihar, Punjab, Udaipur, Rajasthan, Kerala, Jaipur. This is again Jaipur. This is Jalandhar, Punjab. And this is Punjab University, Chandigarh, international conference. Now the question arises that what is the result of doing all this? Delivering lectures, going to different parts of the country. So is there any benefit of this? So I'm just taking one example of that, result of these popularization activity, a real world case of green chemistry in Indian pharmaceutical industry, where wealth came from waste through green chemistry. So I'm just going to take this real world case. But before that, green chemistry is about reducing waste, reducing materials, reducing hazard, reducing risk, reducing energy, reducing environmental impact, and reducing cost. So everything is followed in this real world case. So what was that case? If you know, ranitidine HCl is an important and cheapest anti-ulcer drug available to common. And SMS Pharmaceutical, Hyderabad, is the largest manufacturer of this drug. There are the other manufacturers you can see in the map, but SMS Pharmaceutical is the largest manufacturer of this drug. Now, what happened? Pollution Control Board instructed these two companies, SMS Pharmaceutical and Saraka. They asked uh, them, Pollution Control Board, Andhra Pradesh Pollution Control Board, to stop production of ranitidine because of the emission of methyl mercaptan gas as waste from manufacturing process. So this methyl mercaptan gas is produced in the production. You see the traditional method of production. This is raw material, DMSO raw material, and then there's production of ranitidine followed by methyl mercaptan. And this methyl mercaptan is very toxic, very horrendous smelling gas of having odor of rotten cabbage. And you can smell even at a level of 1.6 ppb. See the toxic effect. And the traditional industrial practice was ineffective. So much input, output, solid waste, unwanted gas. Even then, there is escape of unwanted gas. So this was not the effective process. So the green chemistry came into the play. The green chemist who was working with us for the popularization of green chemistry, Professor Mihir K. Chaudhary, he was the professor and dean at IIT Guwahati. So he designed a catalyst for them. And that catalyst did the wonder. Methyl mercaptan converted to DMSO, that catalyst. And that DMSO is the raw material they were using, and again the raw material is used in ranitidine production. So this way around 40% reduction in the cost was there. So you see the advantage, low capital cost, reduced cost of production, nominal supervision, highly protective, and environmental friendly. So this industry invited me to visit the plant and see the whole process. So I went there also. This was the letter, invitation letter they had sent to me. In that letter, they had written that being inspired by your speech in the conference on green chemistry held at IIT Guwahati, we have concentrated on one of the warning problem of Hyderabad bulk drug industry. So the same way as I'm delivering the lecture in this FTP popularization lecture, the same way I was delivering the lecture in the conference organized by IIT Guwahati, and they were attending that conference, and they thought that green chemistry might help them, and green chemistry did help them. So I went there to visit the plant. You can see they have explained the whole process. Now see, I was not alone. With me, there were two the pollution control board people. One was Dr. D.C. Sharma, Director, Central Pollution Control Board, and another was the MD N. Simha. He is the Member Secretary of Pollution Control Board, the State Pollution Control Board. So these two were there, and they have explained everything. We have visited the actual plant. There was no smell of the gas because there is a peculiar, horrendous smell of this gas, rotten cabbage. So there was no smell. Everything was safe. And these people, pollution control board people, were so happy that they requested us that if you're going to organize another workshop on green chemistry, please invite us also. Now, after returning back, we have displayed this story on our website. And we got a mail from Dr. Reddy's lab that ours is a pharmaceutical industry, manufacturing maranitine as per the website. This is website is development on wealth from waste, say methyl mercaptan gas is to DMSO. Can we know more details on this? So we have guided them, and they are also putting up a plant in Hyderabad. So these are the 12 principles of green chemistry. And very important principle out of these 12 principles is use of selective catalyst. And according to this Nobel Prize winner, Sharpless, catalysis is the engine that drives the development of chemistry. Not only this, catalysts are essential in the synthesis of more than 80% of the chemicals in chemical industry. And one of the great things about the catalyst that even a slight improvement in their performance can be worth millions. So this catalysis work is very important. My group is also working on catalysis area, but you see, to support the importance of catalysis, you just see the Nobel Prize winner working on this area. 2005, 2001, 1973, 63, 18, 2010 Nobel Prize in Chemistry awarded to palladium for palladium catalyzed organic synthesis. So as I said, my group is also working on catalysis, and the homogeneous catalyst. There are two types of catalysts: homogeneous and heterogeneous. Homogeneous catalysts are very active and selective, but the heterogeneous catalysts are not so active and selective, but they are easy to separate and reuse. So what we did, we have combined the activities and selectivity of a homogeneous catalyst with the ease and separation and reuse of a heterogeneous catalyst. And our work was reviewed, and we have published an article on that in Green Chemistry and in Coordination Chemistry Reviews. Not only this, last 2 years publications you can see from our group on the work, catalysis work, Dalton transaction, then material horizons, then inorganic chemistry, then Chem-Sus-Chem, then Chem-Cat-Chem, and RSC, advances, then material chemistry frontiers, then ACS Omega, material horizons, chemical education, ChemCom, ACS Omega, Nature Scientific Report, then Chemistry Select, Green Chemistry, the last one, this is in Green Chemistry. Then again, chemistry select, chem plus chem, then green chemistry, you see sustainable chemistry in engineering, new journal of chemistry, chem, journal of material science, uh, RSC advances, international journal of chemistry, green chemistry again, catalysis science and technology, coordination chemistry reviews, I said, Dalton transaction, and general material chemistry A, again green chemistry, catalysis. And you know, the green chemistry journal is the highest impact factor journal in RSC, one of the journal having highest impact factor. And I got a mail about my article published in Green Chemistry from the editor. Uh, I'm emailing you to let you know that your article, this was one of the most downloaded article in Green Chemistry. So I'm very happy to share with you that at least our work was recognized worldwide. Not only this, even we have published a paper in Nature Scientific Report, and this came that our article is in the top 100 scientific report papers. We got a mail from editor, chief editor, and he informed us. Recently, we had published an article in Material Horizons, published by RSC, and you can see this is also came as we got a mail from editor that this is most popular. This is one of the most popular articles. Even considering the usefulness of this work, we have, or even World Scientific Publisher invited me to write a book on this. So we have written a book on silica-based on organic, inorganic, hybrid nanomaterials and published. Whenever I go to the industry or academia, I just show them the impact factor of academia and just see the pure inorganic chemistry journal or uh, tetrahedron. They all have very low impact factor in comparison to coordination chemistry or the organic chemistry. And if you see the green chemistry journals, the impact factor are very high, like green chemistry 9.1. So just you compare and see this. We are going to industries also. This is the workshop we had organized for industries in Mumbai. Around 300 chemical industry participated that time, and Paul Anastas, John Warner, and DST secretary that time was the Ramaswamy, came and participated. And I was the opening speaker in a conference in a national seminar organized by industry, Gujarat Industries and Pollution Control Board. So this is what. Even after that, this came in the papers also. And this came in the paper. Even our Prime Minister Modi praised about this. Every year, Dr. Reddy's lab, which is one of the major pharma industry in India, every year they used to organize a conference, a symposium on Science Day. So this is in 2019, and in that conference, they invite only one resource person to deliver the lecture from all over India. So this time in 2019, I was invited by them to deliver the lecture on green chemistry. Even JIST, Japan Advanced Institute of Science and Technology, invited me to deliver the lecture on green chemistry. Even this is one of the largest conference in US on analytical chemistry. This time this was with sustainable solution, because our green chemistry was there. So it was every year organized in Crown Plaza, Princeton, uh, New Jersey, US. So every year this is, so they invited me also, the time as a speaker, and delivered lecture on green chemistry and water treatment from vision to action. You know, this is the periodic table, and you see these red metals. See, these are all exhausting. You see the number of years left. So because we are using recklessly, throwing these into the environment, so these metals are going to exhaust. And because of that, you just see the supply of metals are running out. And this is creating challenge in the form of resource deficit. And this can be seen in terms of price rise. Since 2000, the price of copper has quadrupled and price of platinum has tripled. Even this rare earth element um, increase in price by a factor of 20 since 2005. Even indium price rose a staggering 800% in 6 years. The same is in the case for bulk metal, precious metal, and rare earths. So what is needed is to recover and reuse these metals. So even this is a report in Hindustan Times, because China is having rare earth metals. So will China weaponize rare earth metal in trade war with the US? And even recently, the US, this came in Chemical and Engineering News, they are, because of the rare earth, they are giving grants, large grants, for recovery of these rare earth from coal waste, even rare earth recovery from coal waste. So depletion of resources at an alarming rate, so recapture of metals is highly desirable. So we are working on that also. We have designed a chelating polymer, a polymer where we have immobilized, chemically immobilized a metal selective ligand. And that chelating polymer, you just see this is a solution containing chromium. And when we add this polymer there, you just see that is absorbed on that polymer. And then that can be eluted again, we can recover that highly precious metal ion. So this is, you see the chromium scavenger we have developed, we have patented also this, even for iron. And we have designed a online reactor, bioreactor, to recover online these metal ions. So this is the reactor working online. We have even patented this also. Even, this is very interesting story. Like once I was invited to deliver the lecture on green chemistry in a seminar at DAB College, Kanpur. And you see the Kanpur University Vice Chancellor was there. And, so I have delivered the keynote address, and Kanpur actually is suffering from chromium pollution because of the tannery industries. The tannery, they are using chromium and throwing the base chromium containing waste into the water. So there is the large, very severe problem of chromium. So when I delivered the lecture and demonstrated that we can recover that chromium, so this was covered by all media people, and you see the response around more than 5,000 participants what they are in that lecture. Even we got a grant, major grant to organize from ACS to organize international workshop on sustainability and water quality, and in that we have we had invited 6 experts on water quality, and we have demonstrated our technology before them. So this came in Times of India also. DU team claims to have developed a solution for chromium pollution. And we are actually designing different type of chelating polymers. This is for palladium. This is published in Journal of Hazardous Material in Chemical Engineering, then Journal of Material Chemistry, A. We had written several chapters also for green material for sustainable remediation of metals in water, functional silica gel as green material for water remediation. It's again another chapter, water quality issues and solutions in India. There's green chemistry solutions to water pollution. This is the same. I've shown you that this is the chelating polymer we have developed. This is chromium solution, and then here we have added our chelating polymer, and now we have designed a magnetic nanoparticles as chelating polymer, and you see just by using magnet, these can be separated nanoparticle, and clear water is there. We got a major project for this work from DST. As I said, we are working for education also. We are developing educational material. We have incorporated 3 papers in undergraduate syllabi of Delhi University. Even add-on courses is started on green chemistry. Even Miranda House is running an add-on course on green chemistry. This is a general elective course we have introduced from this year. And this is very good course for the students of any branch. They can see the benefit of green chemistry. So this is green chemistry, designing chemistry for human health and environment. Even Central University Rajasthan was the first central university in India started MSc Green Chemistry. And we have designed, you can see here, MSc Chemistry specialization in green chemistry. And we have designed the syllabus for them, green chemistry syllabus. Recently, we had written a book, introductory text on green chemistry, and this book was published by Wiley. Even some of the agencies, they recognize my work, and even the award also. This is an honorary fellowship award. Even this month, this book is published and available, and this is the book Green Chemistry for Beginners, and this book's foreword was written by Paul Anastas, who is known as father of green chemistry. You know, we are designing experiments for the students to inspire them about the green chemistry. And if you want to look, like we are recommending that this journal is a very good journal for students and teachers. Journal of Chemical Education, published by American Chemical Society. This is world's premier chemical education journal. So we are designing experiments and publishing those experiments in this journal. This is the experiment designed by us. It's published in this. And this is another experiment published in this journal. And even these experiments are very popular. We got a mail from editor of this journal that these are the most read experiments. And even University of York in the newsletter given our experiment nanotee as a breakthrough. So we have published a monograph on green chemistry experiment, and the foreword of this monograph is written by Professor Paul Anastas, known as father of green chemistry. And this was released by a cabinet minister. This is another founder of green chemistry, John Warner, and Professor M.K. Chaudhary is also an author of this experimental monograph. And the funding received, we have received funding from Department of Science and Technology for designing and revalidation of green chemistry experiment. So we are designing experiment and demonstrating those experiments for students. And whenever the students are doing the experiments, we are instructing them to just check whether the chemical you are dealing with can be a high risk chemical. So we are recommending them that first you just look for the MSDS, Material Safety Data Sheet. And this is freely available on this website, msds.com. And the importance of these green chemistry experiment is because of the safety, lower cost, and performance. So we have considered following criteria for designing these experiments. These experiments should reduce lab waste and hazards, illustrate green chemical concepts, should teach modern reaction chemistry and techniques, can be accomplished during a typical lab period, and should use inexpensive greener solvents. This is the experiment I just want to share with you. Liquid CO2 as a green extraction solvent. Though for the extraction, and I'm going to show you the extraction of D-limonene from orange peel. So, the solvent, mostly the solvent extraction, you are using organic solvents, but these organic solvents are very toxic, highly volatile, fire hazard, and costly. And here we will use liquid CO2 that is non-toxic, non-inflammable, and chemically benign. And the students, they know that carbon dioxide is a gas or solid dry ice, but how can it be used as a solvent? So we can show them that by using this phase diagram at temperature, at different temperature and pressure, like this phase diagram. Now this experiment requires a polypropylene tube, coiled copper wire, dry ice. You can find from any ice cream stall, and orange peel. So what has to be done is take a copper wire and coiled at one end, and a piece of filter paper was fitted in between the coil. This is take a copper wire, coiled at one end, and piece of filter paper fitted. The polypropylene centrifuge tube tapering and one end was taken and the wire was fitted inside it. This is polypropylene tube was taken and this coiled wire was fitted inside it. The orange peel was grated using a cheese grater and put inside the tube. This is orange peel was grated and put inside the tube. Then this was topped with crushed dry ice like this and sealed with a plug seal cap. The tube was then put inside the plastic cylinder like this, containing water at a temperature 30 to 50. Now just see the demonstration of this also. This is coming in this water tube, and you can see just this dry ice started melting and converting into the liquid CO2, and liquid CO2 is circulating through orange peel. You know, we got the lemonade. Now this saves time, affordable, safe, effective, convenient. Even you can use the same method to extract natural product from coffee, fruits, flour, spices. Even DST invited me to for preparing the monograph for UG and PG, and we have prepared this monograph, which is available on DST website as PDF file. And, you know, the pharmaceutical industry is the most waste producing industry, large quantity generator of waste. You just compare these industries. So what we did, we had written or edited a book on hazardous reagent substitution for pharmaceutical industry. And this book was written with another editor is Rakeshwar, and he is now vice president and head of chemistry division at Dr. Reddy's lab. So this was the book published by RSC Green Chemistry series. So you can see this is a book, and because of the popularity of this book, series advisor on the editorial board. Recently, we had organized an international workshop on green chemistry for societal needs, healthcare, pollution, and circular economies. So this was funded. We have applied to for Newton funding. So this was selected for Newton funding, and we two were the collaborator from our side, University of Delhi and then University of York, UK. So we had organized this. These are the participants, around 30 participants from India and 25 from UK. Not only this, my students are very active in organizing workshops, and so our report of our student chapter, University of Delhi, this came in as very popular green of Delhi published American Chemical Society. From ACE to the chapter that to attend this ACS national meeting in New Orleans. Even one of my students this is one of my students who is working as assistant professor at Hindu College. Now she was selected as participants in this 21st ACSDCI Green Chemistry and Engineering Conference at Washington. And this is the best conference on green chemistry. Every year it was the poster award, this conference. Even we got a green chemistry award also by ACS for our activity in 2017-18. And not only this, we got a global innovation grant. And for international activities, this is to organize a workshop, educational workshop. We got $5,000. So we had organized versus the participants of that workshop. And Mary Kirchhoff, you can see from ACS, President, American Chemical Society's Green Chemistry Institute. And recently, again, our international chapter was selected for this award, ACS Symposium series. Now we are organizing this series in November. We got another award for 2019-20 activity. This is International Student Chapter Award for dedication and commitment to chemistry and the community. So the ACS has given us this honorable mention award. Now this is the last slide. Just I want to share with you. You know, whenever we go for any experiment or any project or anything, we look, whenever we take a material, we look for these properties like state of matter, color, melting point, boiling point, solubility, electrical conductivity. And the day when we will consider these two also with these toxicity and impact on environment, that day I will stop delivering the lecture on green chemistry because chemistry itself will be green. So thank you very much for your kind attention. So over to Malika.
Thank you so much, sir. It was such a pleasure to hear you talk about green chemistry, sir. It was an enlightening talk, and I can't tell you how much discussion it has generated on the YouTube link, that live chats. So, sir, we'll share the YouTube link with you. But before I do that, can I take the questions from the participants from
Yeah,
the
yeah,
YouTube
please.
channel? Yeah. So, so, sir, it has generated so much curiosity pan India that I'll just take up questions one by one. So, the first question is,
Yeah.
how can we implement the concepts of green chemistry in UG and PG laboratories? And if you can let them know the possibility of it, Professor.
Malika, you know already that we are working for that. We are designing, like in the lecture also, I told you that we are working, we are designing experiments to inspire students, and we are showing them the same experiment that is and green chemistry. So this way we are inspiring students to come up because green chemistry is not a separate chemistry. This is the same chemistry, but doing in a safe way, not using the toxic or harmful chemicals. So we are publishing books also, we are designing experiments, and these monographs are available if anyone interested. And even we have recommended that Journal of Chemical Education. That's a very good journal if anyone interested in that, in green chemistry experiments, go through that journal.
So, the next question is, how to take up the membership of GCNC?
It's very easy. Just from our website, I've given you the website address. Just from our website, they can print out the form, you can fill up the form, and a very important column for that form is why are you interested in green chemistry? So he should write that and then submit that. We can give. We want more and more people to join our network to help us in doing the green chemistry activities.
Right, sir. So, So there's a question from someone who has asked, to develop more aspects of green chemistry, is it possible to have GCNC chapters or forums in their university areas?
Yeah, no problem, because we are involved in networking. So they can have a chapter there and we can network and we can inform them about the activities we are doing or whatever is information is available.
So everyone has to visit SIR's website, Green Chemistry Network Center's website. Sir, another question is, somebody has asked, kindly suggest simple process for lab waste disposal. So that is also
Simple
a
process
question.
for lab.
So lab
You
waste
know,
disposal.
the problem of green chemistry is this: green chemistry never advocates the waste. You know, the first principle of green chemistry is prevention is better than cure.
Yes. Sir.
So we have to do those things, those processes where the waste is not created. So it's not like that. So green chemistry means initially you just think over that no waste is created. Though now the like how to clear that waste, there are other agencies, you can contact them. Like in when I did the postdoc in Japan, we are separating the solvents and other things. Then agency comes and that takes up like taking up those cans or other things, solvents, and disposing.
There is another question, but I think they can just Google and find it. They've asked the link for the green chemistry chapter. So I think it's already on the Google. They will just type Green Chemistry Network Center and they should be able to find it. But there's one question on that also. So there is a question. Is there any possibility to make antiviral masks for people living in environment or people living environment? This is how it has been framed. Antiviral mask for people.
Now, again, Dr. Malika, actually, whenever I go places to, we are, wherever he wants the solution or the solution of any problem, can write to us. We can approach the person who is expert in that, and then we can get the solution. But he should be involved. It's not like that I am the green chemistry expert or something. I'm not expert in all the areas.
But sir, we think you are an
Okay,
expert.
so he can approach the concerned person who is
Yes.
working in this area.
Yes, sir. So, uh, so the last question, I think I'll take this. Did polymer immobilized? The question is written like this only. Did polymer immobilized require large-scale testing after lab scale? I think I don't know what it means, but this is how it has been framed.
Actually, we have shown that how can we get online extraction of the metaline, and that's why to get the large scale, we got a major project from DST worth 80 lakh. So we are working on that, getting a reactor on large scale. So we want that because the recovery of those precious metaline is very important now.
Right. So I don't know whether this is a question. I think this is a comment of sorts. I think the question is, can green chemistry be really implemented in industries with so much corruption? So whether it is a remark or a question, but this was something that was written in the chat box.
Actually, that is a problem in India. In US, EPA is very strict. And here also, I've shown you a green chemistry real world case. that real world case came, and then industry people approached us or they came forward when pollution control board said you stop doing this thing, stop the production, shut your plant. Then they came and approached us. Then they looked for green chemistry solution. So this is again our pollution control board should be very strict in this regard.
Yes.
There should not be any corruption or anything.
Yes, sir. I think it's a huge country. India being a huge country has some of its limitations there also. So, sir, thank you so much. And we can't thank you enough for sharing this talk with us. You've mentioned the importance and the developments of catalysts in the green chemistry. Sir, I am sure by the end of this faculty development program, all our participants will be convinced. I'm sure the ones who are live right now are already convinced, and the others will be watching it later, will also be convinced that whatever be the field of science, chemistry is actually the catalyst for change. And so your lecture, as always, resonates with the theme of our FDP, and that's why we wanted you to give a talk. We were sure that we wanted you here. Thank you so much, sir. It was a pleasure to hear you here. Now, with
Thank
this,
you.
I think we can wrap up this session. But, sir, would you like to add anything before you leave? Another 2 words to say.
Yes, I would like to thank you for giving me a stage there. We can promote the green chemistry.
No, sir, it is our pleasure to hear you. So now with this, I think everyone, thank you so much. With this, we wrap up our session. On behalf of the Department of Chemistry and the TLC Ramanujan College, I would like to express my gratitude to you, sir, for the sparing your valuable time and sharing your vast expertise with us. And last but not the least, all the participants who have been able to take time on a weekend from the schedule to hear the talk in a live mode. This talk will be available as a recorded session on the LMS portal for you to view in case you would like to hear it again. And we'll be uploading the quiz and the assignments for you during the day. As always, you have to check the portal from time to time for all the updates that are there. There was a question on the live chat box that somebody had still not accessed it. I'm sure if you had accessed the LMS portal, all the assessments and the quizzes are uploaded at 9 o'clock along with the videos. Please take a look there. We are towards the end of the FTP. So by this time, you should all be now familiar with it. So, Anshika, would you like to add something here?
Thank you so much, sir, for being a part of this faculty development program. And it is always a pleasure listening to your talk. Thank you so much, sir. And yes, the participants, they should check the portal for a regular update.
Amrita ma'am, you would like to say something to sir?
Yes, Professor Sharma, always nice to hear you. And so happy that you mentioned the add-on certificate course, which was initiated at Miranda House. But now, since green chemistry is part of the syllabus, we have stopped that add-on certificate course. But yes, your lecture took me back to your lecture at the add-on course when you had come to deliver a lecture. And so I have actually relived a lot of my old memories and very happy to hear them. Thank you so much, Professor.
Thank you so much, sir, for sparing your valuable time. It was a pleasure to hear you. As always.
So I'm leaving.